Hey everyone, welcome back to my YouTube channel. Myself Janavi MS from the Department of the Computer Science and Engineering. Today we are gonna discuss the subject is database management systems. In that we are gonna discuss Boyce Code normal form. Let us see introduction to Boyce Code normal form. Boyce Code normal form is also known as a BCNF. Is a normal form used in database normalization to reduce redundancy and improve data integrity. It is based on functional dependencies where a determinant uniquely determines the values of an attribute. BCNF is stricter than third normal form or 3NF and ensures that all determinants are candidate keys. Boyce Code normal form BCNF is a normal form used in database normalization to reduce redundancy and dependency issues. It is based on functional dependencies and ensures that a database table is free of certain types of the anomalies. BCNF is considered a stricter form normalization compared to 2NF or second normal form or third normal form or 3NF. Understanding functional dependencies. Functional dependencies are constants between the two sets of the attributes within a relation. They represent relation between attributes where the values of one set of attributes uniquely determines the value of the another set. Identifying functional dependencies is a crucial for the determining the normal form of a database. Key concept of the BCNF. In BCNF, a relation in the highest normal form if for the non-trivial function dependence xy, x is a super key. A relation in the BCNF if every determinant is a candidate key. BCNF eliminates a anomalies such as a insertion, update and deletion anomalies. Example of BCNF. Consider a relation or ABC with functional dependencies AB and BC. In the case relation is not a BCNF as a determinant B is not a candidate key. To normalize the relation to a BCNF, we split the relation into two, R1 AB and R2 B and C. Benefits of BCNF. BCNF reduces redundancy by eliminating partial dependencies and ensuring that all determinants and candidate keys. It improves data integrity and by preventing update anomalies by ensuring that data remains constant. Queries on database in BCNF are more efficient as the data is structured without redundancy. Benefits of the Boyce Code normal form. BCNF reduces redundancy in database tables by eliminating partial dependencies. It helps maintain data integrity, constancy by preventing certain anomalies. BCNF simplifies database using the ensures that updates to the database do not lead to unexpected results. Challenges in achieving BCNF. Normalization a database to BCNF by result a splitting relation which can lead to an increase in the number of the tables. It requires through understanding of functional dependencies and candidate key to ensure proper normalization. Denormalization may be necessary in certain cases to optimize performance while maintaining data integrity. BCNF versus other normal forms. BCNF is stricter than third normal form or 3NF as it requires that all determinants are candidate keys, while 3NF eliminates transitive dependencies. The BCNF goes to a step further by addressing all steps of dependencies. BCNF is essential for maintaining data integrity in complex databases with multiple relationships. Implementing BCNF in database design. To implement BCNF, start by identifying functional dependencies and candidate key in the database schema. Normalize the relation by splitting them into smaller relations to ensure that each relation in a BCNF. Use tools that techniques such as a normalization algorithms to automate the process of achieving BCNF. Best practices of BCNF: regularly review and update the database schema to ensure that it remains in BCNF, as that it involves document functional dependencies and candidate keys to facilitate further modifications and optimization. Consider the trade-off between normalization and performance to strike a balance that meets the needs of the applications. Functional dependencies. Functional dependencies is a database table describe the relationship between attributes. A functional dependency AB means that every unique value of A, there is only corresponding value of B. Identifying functional dependencies is a crucial in determining the level of normalization needed for a database. Anomalies in database tables. Anomalies such as insertion, update and deletion anomalies can occur when a database table is not properly normalized. Insertion anomalies happen when certain attributes cannot be inserted into a table without additional data. Update anomalies occur when changing a value of in one attribute requires updating multiple rows. Boy's Code normal form rules. In BCNF, every determinant must be candidate key. If a table has multiple candidate keys, each non-trivial functions depends must have a candidate key and its determinant. BCNF ensures that there are no partial dependencies in database table. Example of BCNF violation. Consider a table with attributes student ID, course ID, student name and course name. If the functional dependency student ID, course ID is equal to student name words but student ID alone candidate key, BCNF is violated. To normalize the table into BCNF, we need to split into two tables, student ID, student name and course ID and course name. Comparison with 3NF or third normal form. Both BCNF and 3NF are forms of normalization that aim to reduce data redundancy and dependency issues. BCNF is more strict than 3NF as it is eliminates all types of anomalies including partial dependencies, while 3NF is often considered sufficient for most database designs. BCNF is preferred for databases where data integrity is critical. Common misconceptions about BCNF. Some may confuse BCNF with 3NF or think that BCNF is always necessary for all database tables. It is important to access specific requirement of a database and its data dependency before deciding on a level of normalization needed. Implementing BCNF may not always be practical or necessary for every database design. Implementing BCNF in database design. To ensure a table in BCNF, analyze its functional dependencies and candidate keys. Normalize the table by breaking it down into smaller tables that satisfies the BCNF rules. Consider the trade-off between normalization and performance, as highly normalized tables may require more complex queries. Conclusion: Boy's Code normal form is a critical concept in database management systems by reducing redundancy and ensuring data integrity. By eliminating partial dependencies and ensuring all determinants and candidates keys, BCNF helps maintain a well-structured and efficient database. Understanding BCNF and its implementation best practices is essential for database designers and administrators to create robust and scalable databases. Boy's Code normal form is a crucial concept in database management to ensure data integrity and reduce redundancy. By following the BCNF rules and normalization database tables, approximately we can minimize anomalies and maintain a well-structured database. Understanding BCNF and its implementation can lead to more efficient and reliable database systems. Thank you.